Hi guys, this is just a test recording, and the whole idea is that I shall try to cover the self-study portion in the form of a few video classes. So let me just try how this will go, and also we need to look at the quality of the recording. So you know that the bulk properties of matter is being given as self-study, and what I should do now is cover at least one property of matter. So what is the fundamental idea behind this? I think we've already explained. So we try to obtain some property of the material with the help of an experiment, and this property when properly tabulated will help us to predict and do some useful calculations. So that's the main idea. So here's the first experimental property of, let's take steel or any metal. So typically the experiment is performed in the following way. You hang up a steel wire, and it is understood that the cross-sectional area of the wire is well known and accurately measured. Then you hang a weight here, and what will happen? So what will happen is that this wire will slightly deform, and if this was the original length of the wire, so if this is the original length of the wire, let's call it L, one can expect, I'm just drawing a magnified image here, one can expect an increase in the length of the wire because there is an application of a force on the wire which we shall call as F. So here are all the important quantities. The original length of the wire is L, the cross section of the wire is D, and now this increase in length, which I have shown in yellow, we shall call it as the change in length or elongation of the wire under the action of the force F. Now the important quantities for us are there on the board. This F divided by the area is going to be an important quantity, and this is going to be called as stress. Up front, it's very important to write down the unit of stress. The unit of stress is Newton per meter square, or you know that one calls Newton per meter square as Pascal. So this is the first thing that we have noted down. Stress is force by area. The second important quantity is also there on the board. It is the change in the length or the elongation divided by the length of the wire, or in other words, elongation per unit length. Now this is called strain, and this particular kind of loading here, where I am putting the wire under tension so that the length of the wire increases, is called a tensile force. So this experiment is subjecting the material to a tensile force and measuring the stress and the strain under this experiment. Now what happens when you keep changing the force and therefore keep changing the stress, and then of course as you do that the elongation also changes and you measure that as well, and the strain also changes. So you have an experiment where you have different values of stress and different values of strain. Now with these values, what you're supposed to do is plot stress versus strain, and this particular graph by far is a very important and useful graph for the material. So in this case we are saying that the material is steel. Now if you plot stress and strain, then as is good practice, this might be a good idea to write down the units. Now what shall we write down as the unit for strain? The unit for strain we can write down as mm per mm. I mean, just to remind you, this is delta L by L. So delta L we can call it as mm and L as also mm. Now if you do that, this is basically, as you can see, it is unitless. There is no unit for this delta L by L or strain. Now with that in mind, and the fact that strain is unitless, but still we sort of write it as mm per mm. Now what is the kind of graph that you can expect? The graph might look like this, mostly nice and simple, a straight line. After the stress increases beyond a certain level, you can expect some complicated behavior, which for our syllabus is to be ignored. So kindly ignore this and focus on the easy part. And the easy part, I think, is the fact that it's a straight line. Now it's a straight line passing through the origin. Okay, so that's another straightforward observation, a straight line passing through the origin. Now if that is the case, then one can expect the experimental result to be stress is equal to the slope, which I'm going to denote as E, because I know that we're going to give a name for the slope, into strain. So this is the simple result that you're expected to remember. Now this constant or the slope is called the modulus of elasticity, and this is a constant for steel, and that is a property that will be tabulated for us. And finally, how will it help us to make a prediction? That's the last part of this video. So just let's write this down. Stress is directly proportional to E into strain, and you will get it from the slope of this graph. In other words, you will get it from the experiment. So just remember this formula: stress divided by strain is Young's modulus, and all we need to now is write down this formula very neatly. Stress, you remember, is F by A, and that is equal to the elastic modulus multiplied by strain. And all I need to do is substitute the formula for strain, which is delta L by L. Now this gives us a wonderful formula for the elongation of the steel wire, and you can see that delta L is equal to FL by AE, and this is a formula that is mostly memorized by students. It's a worthwhile formula to memorize, FL by AE, and quickly repeat what it is. A is the area of cross section, E is the property of the material, which is the main chapter, with the modulus of elasticity, and F is the force, and L is the initial length of the wire. So with the help of E, we are able to predict the deformation of the wire. So that is the end of this part of the material property E. So one last thing here is what is the unit of E? Now you can see here that strain is unitless, and therefore the unit of E is the same as that on the left hand side. So I'm just going to write it here. Unit for E is the same as F by A, is the same as Newton per meter square and sometimes called Pascal. Now, what is the value of E for steel? I am not able to recollect, but I'm definitely remember to tell you next time. But it is a value worth remembering because steel is such a important material. And so with that and this formula, I think this is the right time to pause this video.